All right. Welcome to lesson number 4 of chemical formulas. Today we are going to talk about acid and bases. And we're going to tie in how are you going to recognize what an acid or base is. So we've been talking about what an ionic compound is. It is I hope you remember, a metal and a nonmetal. And then a polyatomic compound is like an ionic compound, except it has a polyatomic compound with it. And then we talked about molecular covalent compounds. And now we're going to talk about what an acid and a base is. So before we get into the lesson, let's watch this little video on what an acid and a base is and see if you have anything at home that you can think of as an acid and a base, because I bet you do. You use them every day, and this just will make you think of everyday uses of chemistry. Everybody uses chemistry every day. All right, let's watch this.
Hello friends, today we'll learn about acid and base. Acids and bases are two specific types of chemicals. This orange juice looks so yummy. You know approximately all liquids are either acids or bases. Whether a liquid is an acid or base depends on the type of ions present in it. If it has so many hydrogen ions, then it's an acid. If it has so many hydroxide ions, then it's a base. It's that simple. See this scale? Scientists use this scale, called a pH scale, to check how acidic or basic a liquid is. The pH scale is a chemical detector for hydronium and hydrogen ions. pH is a number ranging from 0 to 14. What falls from 0 to 7 are acids, with 0 being the strongest. Whatever comes within 7 to 14 are bases, with 14 being the most powerful base. A liquid is neutral if it has a pH value of 7. Any acid that dissociates 100% into ions is known as a strong acid. If it does not dissociate 100%, it's called a weak acid. There are a lot of strong acids and bases in nature. Few of them, like boric acid, is used in insecticides. Some acids, like hydrochloric acid, is very dangerous. But some of them are so helpful. Many plants have acids and bases in their seeds and leaves. This lemon is so sour, my friend. Citrus fruits like oranges, grapes, and lemons have citric acid in their juice. This is why lemons taste so sour. Let's see some uses of acids and bases. Remember when your stomach was upset after eating junk food, doctors gave you antacids? These include sodium bicarbonate, or baking soda, and calcium carbonate. They are bases and work by neutralizing stomach acids to water and carbon dioxide gas. The stomach uses hydrochloric acid to help in digesting food. This strong acid also kills bacteria and keeps you healthy. Very good, buddy. When you exercise, muscles produce lactic acid. Oh, careful. There is cleaner in the floor. It is slippery. Bases feel slippery because these are soapy in nature. That's why some of them, like sodium hydroxide, is used in cleaners. Some common household items that contain bases are baking soda, drain cleaner, washing powder, and toothpaste. Some common household items that contain acids are yogurt, vinegar, lemon juice, and batteries. Now you know a lot about acids and bases. Stay tuned for more videos.
All right. Well, I told you we use chemistry on a daily basis. And that video just shows us that we have acid and bases in our home, and we use them all the time. We've used them our entire life. And just like at home, we use them also in the chemistry lab. And so whenever we have labs, we have to be careful. And just like we've already talked about, when an acid dissociates, it forms ions. And I think you remember what an ion is. You can have cations that are positively charged, they're positive, or you can have anions and they're negatively charged. And ions, they either gain or lose electrons. Okay, that was just a little refresher of what we've learned in the past. So let's talk about what an acid actually is. There are two types of acids. There are binary acids that is actually a hydrogen and one element. Then there are oxyacids. It's made up of 3 parts. It is hydrogen, a polyatomic ion that has oxygen in it. There's 2 ways to name an acid. The binary type of acid is named with the hydrogen reduced to hydro. So you take the hydrogen and it's hydro. You take the root name of the element, drop the last syllable, and add ic. So for instance, the element compound would be HBr. HBr. So you've got hydrogen and bromine. So you have hydro, and then bromine is the root name. Drop the INE, add ic, acid. So hydro, root name, plus ic, acid. HCl, hydrochloric acid. Hydrochloric acid. H2SO4, remember sulfur, H2SO4S, the oxidation number is a -2, so you would have H2SO4. And then for HF, you would have hydrofluoric acid. So binary means 2. And note, you recognize an acid by looking for an H in the front. H, 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 H. All right. So, oxyacids. Oxyacid. Hydrogen plus a polyatomic ion that contains an oxygen. It has to have an oxygen in it. See this oxygen? It has to have an oxygen in it. So how do you name it? You have the root name, the suffix, acid. So you take the root name of the polyatomic ion. So NO3 is the nitrate ion. NO3 is the nitrate ion. Who remembers where we get that name from? Everybody should have their reference chart. If you turn to page 7 on your reference chart, you will have the polyatomic ions listed. It has the symbol and the polyatomic names beside of it. If you do not have this printed out, we went over it in lesson 2. This is also in module under ions where you can print it out. So you take the nitrate ion, you drop the 8, add ic acid. So it's HNO3 nitric acid. The nitrate ion has an oxidation number of -1. So you would say HNO3 -1 crisscross. That's how you write it, and you get HNO3. Nitric acid. Sulfuric acid. It has an oxidation number of -2. Hydrogen +1. Crisscross H2SO4. It's the sulfate ion. You drop the 8. It's the sulfuric acid. Sulfuric acid. It's important to remember that these hydrogens are just acids when they are in water solutions. Hydrogen chloride is a gas until it's dissolved in water. When it's dissolved in water, it becomes hydrochloric acid. Remember, acids are compounds until they're dissolved in water. Acids are compounds until they're dissolved in water. HCl is hydrogen chloride until it's dissolved in water. All right. The bottom 3 here are the 6 acids that you should memorize. These are the ones we would use in lab if we were not in the COVID environment. But these are the ones that you would use on the test. So we just saw hydrochloric acid is where? It's in your stomach. And so that is what our stomach uses to break down our food. It fights off bacteria. Sulfuric acid, I wonder if anybody knows. It's in batteries. Acetic acid, we eat it. It's vinegar. It's in pickles. What about carbonic and phosphoric acid? Do you think you drink those? If you said yes, you're correct. Those are in our soft drinks. We probably drink those on a daily basis. So acids are in our daily lives. What makes acids dangerous? Acids are dangerous based on their concentration. As they get more concentrated, stronger acids become more dangerous. They can burn holes in your clothes, just like at the beginning of the year when we were talking about safety. I shared with you a story about one of my students last year where she bumped into acid on one of the lab benches and it burnt a hole in her pants. So you have to be careful. And it was hydrochloric acid. It was just concentrated hydrochloric acid. All right. So we also have bases. So what's the difference between an acid and a base? An acid is at the bottom of the pH scale and a base is at the top of the pH scale. An acid has H at the beginning, of its name, well, bases have hydroxide. And if you remember from polyatomics, hydroxide is a polyatomic ion. It is OH. It has a -1 oxidation charge. Where are the metals located? We learned that in an earlier module when we talked about the periodic table. They are on the left of the, do you remember? Staircase. They're located on the left of the staircase of the periodic table. So if you have a metal and a hydroxide, you have a base. Sodium hydroxide is a common base. What is the formula? You should know how to write that now, based on this unit. Based on the polyatomic lesson that we did, lesson number 2, you have a metal, you have a polyatomic ion, you should be able to write the formula for a base. Potassium hydroxide, potassium is a +1, KOH. Calcium, calcium's oxidation number is +2, Ca +2 -1. Do you need parentheses? Ding, 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 ding. If you said yes, you're correct. CaOH. Well, just like acids, bases are just as strong. Bases can be destructive and corrosive just like acids. They can eat holes in your clothes. Based on the concentration of a base, the stronger the base is, the more damage it can do. Bases are corrosive too. So you have to be careful with acids and bases. You have to use lab safety around all chemicals. So, with naming oxyanions, you've got your polyatomics, and oxyanions change with oxygens. Oxyanions change with oxygens, and you do not need to memorize this chart. I am just trying to show you, and I do have a typo, so I want to fix that right now. This should be chlorate, perchlorate, not right, perchlorate. Naming oxyanions change with oxygens. So the most common is at the top. You've got chlorate, sulfate, and nitrate. If you take one oxygen away, you get chlorite, sulfite, and nitrite. If you take 2 oxygens away, you add hypo to the front. Hypochlorite, hyposulfite, and hyponitrite. If you add 1 to the most common, you add per to that name. Perchlorate, persulfate, pernitrate. So this is just a little helpful hint, something that you can look at. But some of these polyatomics was on that list. And so if you're interested in chemistry, I wanted to give you an idea of how scientists named the polyatomics. You do not have to memorize this. Well, let's look at some problems. The formula for magnesium chloride. So let's go back to our little sheet, or you can look on your polyatomic. Magnesium chloride. So chloride is ClO2 -1. Magnesium, you have to look at your periodic table, is -2. What was chlorite? What's the oxidation? -1. Does it need a parentheses? Yes. So, if you put number 2, you are correct. The next review question. Formula for magnesium perchlorate. Perchlorate. All right, let's go look at that chart again. Perchlorate. Perchlorate was if you add a 0, you add per, so that's ClO4, but we'll go check. Perchlorate, ClO4, oxidation's -1. So magnesium's 2, ClO4. If you picked number 4, you're correct. And the last one is hypochlorite. Hypochlorite was to lose 2 oxygens. 2 oxygens. So if you picked number 3, you're correct. All right. Well, that is the lesson for the acid and bases. And it is a short lesson. I do want to go over the worksheet 7.10 and 7.11. Because the next thing we're going to do is bonding. So 7.10 and 7.11 is a worksheet that ties all of the 4 lessons together. And it's really important that we work on these, because if you do not get how to name ionic compounds, polyatomic compounds, covalent compounds, and acid and bases, and be able to do that in a formula versus a name, I don't think you're going to do well on the test. And so this is the best way to review for the test. But before we do that, I have this really cute video that I want to show you that ties acid and bases into bonding for our next unit.
Yeah. Okay. It's a pH scale for solution using acid or base. Telling levels of hydrogen ions present. Acid thermal hydrogen ions H plus concentration like a lemon. It tastes pretty sour, probably like a level 2 on the pH. Give it a test initials red on the lip. 0 to 7 acidic. Hydrogen ion for thicker than lead. And moving over to the blue litmus. It's a base with a taste slippery fluid. Hydroxide ions always find a success. Like a product for your drain. Need an unclogged element. Another name for a base. Alkalized pH range from 8 to 15 high ions. And a base never hydroxide like toothpaste, soap, cleaning products like iron. And when a base and acid mix and neutralize H plus and OH minus combine, turn it into plain water. H2O plus on the side is a salt. For example, sodium chloride. Mixing up with acids and what it makes is salt and water. Don't forget what the pH is. A measure of hydrogen ion concentration in an aqueous. Neutralize reactions of water from acid and base. Neutralize reaction. Neutralize reaction. Neutralize reactions of water from acid and base. Neutralize reaction. Neutralize reaction. Let us move to the new definitions. 1920s, Montefiore, a new theory about all this. Talking about the proton transfer. Acid and bases behaving outside of water. Said no matter the solvent. The aqueous gases, liquids and solids. I said no matter the solvent. The aqueous gases, liquids and solids. Acids donate protons. Bases accept protons. So bases represent reactions, acids don't need them. Bases, acids react protonic staging. Steering benefits, it applies to a wider range. Acids donate protons from the theory, Bronsted and Lowry. Acids donate protons. Acids donate protons. Bases, 6 and protons from the theory, Bronsted and Lowry. Bases, 6 and protons. Bases, 6 and protons.
So just so you saw that, what did that do? It gave some of those hydrogens away for it to bond. That's so cool. And that is what we're going to talk about next week. Anyways, okay, so we're going to study for our test, and we're going to do 7.10 and 7.11 as a worksheet. So 7.10, we're writing chemical formulas. I've given you the name. It's all 4 of the lessons put together on one. So I want to do some of them together, and then I want you to stop and do the worksheet. Trust me, I want you to practice. If you practice, I promise it will help. Okay, so let's do a couple together. Silver, 1 permanganate. Silver is a transition metal. 1 is your oxidation number. It's the Roman numeral. And permanganate is a polyatomic. You can get that from the chart. AgMnO4. All right, let's look at 10,2-phosphate. 10,2-phosphate. 10 is the 10 is the transition metal. 2 is the oxidation number for 10. It's the Roman numeral. And phosphate, it's a polyatomic. SN3. The oxidation number for phosphate is 3. Parentheses, PO4, 2. Potassium nitride, K3N. Potassium is a +1. Nitrogen is a +3. You just write your oxidation numbers and crisscross. There's no polyatomic. There's no Roman numeral. It's not a transition metal. It's just ionic. All right, carbon dioxide. It's covalent. So remember, the prefix tells you the number. There's no mono on the first one, so there's 1 carbon and 2 oxygen. Carbon dioxide. Look at lead 2 carbonate. Lead 2 carbonate. Carbonate's a -2 oxidation. Lead's a transition metal. 2 is the oxidation number. They reduce. PbCO3. PbCO3. Sodium chloride. Good old sodium chloride. That is our table salt. NaCl. Chromium 2 chloride. That is ionic. Chromium 2 is the oxidation number. Cl2. Chromium has an oxidation number of 2. Cl has -1. Crisscross. Sulfur hexafluoride. Sulfur's mono. Hexa tells you there's 6 fluorine. And let's do one more. Let's do dinitrogen tribromide. So 2 nitrogen, N2, Br3. All right, pause the video, and when you come back, you'll see the answers. But Try, try, try. I can't stress to you enough. All right, guys. Here's the answers for 7 1.0. I hope you took the time and filled these out. Now, I'd really like for you to pause the video and check your answers and correct the ones that you got wrong. If you have any questions, please send me a message. You can email me, you can send me a Remind question on the Remind app, or you can send me a message in Canvas. I just ask that you send me a message and do not be afraid to ask questions. All right, let's try 7.11. Okay, guys, so here's 7.11. And this is the last worksheet for the unit. And so in this one, I've given you the formulas and you've got to write the names. And so I think this could be the hardest because you have to determine what type of formula you have. Is the compound ionic? Is it ionic with a polyatomic, so you have to recognize it? Is it covalent? And then if you figure out that it's an acid, do you give me the acid name or do you give me the covalent name? So that's kind of cool. All right, let's do a couple, and then I'm going to let you try it on your own. The first one, Al2S3. What type is it? It's ionic. It's aluminum sulfide. Aluminum sulfide. All right, NH43PO4. That's 2 polyatomics. It's ammonium phosphate. Ammonium phosphate. All right, let's look at this one. SnCl4. SnCl4. What is that? 10, 4 chloride. 10, 4 chloride. Don't forget, if it's a transition metal, you have to use the Roman numeral to tell the oxidation number. All right, sodium hydroxide. What is that? Do you remember? In water, it's a base. It's all about the base. Okay, I know, Miss Nicholson's crazy. All right, MgO. MgO. It's magnesium oxide. Okay. Let's see. Cu parentheses Cl32. It's a transition metal. It needs a Roman numeral. Copper 2. Oh, this is where my iPad's a little messed up. Chlorate. And the last one, let's do a covalent one down here. H2O. If you put water, it's wrong. Dihydrogen monoxide. Dihydrogen monoxide. So us chemists, we're funny about our water. We like dihydrogen monoxide instead of water. Anyways, this has been a wonderful unit. I hope you've enjoyed this lesson, and I'm looking forward to bonding, because now we're going to take all of these formulas and put them together into how they bond together. They either lose electrons, share electrons, and we're going to learn all about that in the next unit. All right, so here's the answers for 7.11. Make sure you check them and fill in and correct the ones that you got wrong. Guys, we have covered so much, and I am so confident that you are going to do amazing on the test, okay? And remember, all this formula stuff we're going to use in bonding, because now you're going to be able to name the compounds that we're going to bond together, and you're going to know how to do it. All right, good luck tomorrow. Let me know if you got any questions.